Hello. Today we will look at how to split train and test set using pandas. So we have a panda data frame and we want to split into test and train set. The thing is, we have seen in one of the previous videos that we could use numpys and use the random permutations to choose that to do the splitting. But when the data is updated, for example, let us import the data. I am using the same data set, the housing data, that one of the data set that we have seen previously. So for pandas as PD. So the data is SV and there's a df equal to so this is the data that we have. So suppose that we update the data and say add a few lines of data at the end of this set. Then the trouble is that if you use the random permutations, the random method that we have seen previously, it wouldn't work, because again we will get some jumbled data, and that it will randomly choose data from everywhere, from the updated and the old one. So we don't want that. We want to uniquely choose the data. Suppose we have already added some elements to the test set, we want to keep that as it is and pick a portion of the newly added data for both the train and test set. So we can use the md5 hash. So we use the hash lib. The first thing, so we can see that let us see, for example, hash lib.md5. Basically, if I have if we pass any string, say a, and if we call digest of that, so it basically returns a unique pattern or it converts into a unique string or a unique pattern for us, corresponding to each string or any letter that we give or a number. It will give us a corresponding unique pattern. So it is so we could use this. So what we, for example, we can pass 1 here, and this is a unique. So what we are going to do is we are going to use the index value 0, 1, 2, 3, etc. here and convert it into the md5 hash. So for that we won't be able to pass directly. You can see that suppose if I just pass 1 here, it will give us an error. So we need to convert it into numpy int 64. So this object supporting the buffer API. So numpy int 64 basically supports that. So we can use, and we will just use only the first byte, the 8 bits of the first byte. And let us suppose now if I pass, for example, for I in range say 10, we could do this. I, and we pick up the first byte. So we get this unique numbers. Basically we are picking up the last byte, this guy, and so it goes from 0 to 10, and we are getting the corresponding numbers here. So each are correspondingly so unique. Every time if I run it again, it's the same thing. So now what we are going to do is we have our df. We are going to compute, take the index value 0, 1, 2, etc., and compute the hash of that. So what I'm gonna do is add an index column to this. So we can say df1 equal to reset index reset. So if you look at df1, so we see that we already added a column, the index column. So now let us write a function which is the different calc md5 hash. Well, and we say, which is basically a hash lib. We can put maybe index value dot md5. We pass int numpy dot int 64 index dot digest, and we pick up the last bit. So and we say that that is less than 0.2 times 256. So this one 0.2 is our test ratio. So now, so if you look at that, 0.2 times the test, you can say test ratio is 0.2. So 0.2 times 256 is basically 51 around. So why that is, so let me show you. So what we have is the ratio is 0.2. We said 0.2 times 256. The md5 hash or whatever what we're getting is like generating numbers randomly. It's quite it's random, even though there's a one-to-one correspondence between each number and the corresponding hash. It's a random number with a uniform probability. So you could say we get, say, 1 to 256. So now what we have here is, suppose the probability of getting the first one will be like 1 by 256. Now this is giving us around 51. So if I look numbers up to 51, I have a probability of getting it is 51 by 256, which is equal to around 1.199 or approximately 0.2, or you can say 20%. So in other words, if I look for numbers less than 51 in the md5 hash, if I calculate the digest and pick up the last byte and keep only numbers which is less than 51, I have 20% probability of getting them. In other words, I'll have 20% of the whole data set in the test set. So we have this function here now, and which will check if it will calculate if the number is less than 51. Now basically it's very simple. So we can take the df of index in the column and say apply. We'll apply a lambda function x, and which will call calc md5 hash with the x, and index dot apply. So df2, okay, so this is df1. So import hash lib. So say it's there is some errors here. So basically we have to redefine, we need to return, I forgot return. So we need to do that. We need a return statement, obviously. And so now, so this is what we get. So df1 index, so we have the length, we get total, so we can assign this to say, we say in test set. So this guy will keep that much in the test, which will be 20%. And we can now just index, we get the test set as test set will be, you can see, we can just take df1, look here, we can just say in test set. That's so we get, say this is, so we already got it. So we have test set is basically 4 2 7 8 rows, and now we can also calculate the train set, which would be same thing. We can use the knot of that. So train set. So we have split into test and train set. So the idea is very simple now. Since, as I told, see, we have one-on-one correspondence between each of the index values and the corresponding hash. So when you add the values at the end of this data set, it will only correspondingly pick up, it won't pick up anything which is already inside the test set. It will only pick up which is not, because there is a one-on-one correspondence between these numbers. So you could write all this as a complete function, so that you don't have to do this again and again, and which will be much more effective. So thank you for watching.